Hello and welcome back to the show. My name's Relevant. This is Do All the Things. And on today's episode, we're going to be looking at a Bugera Infinium 1960 head. We're going to be talking about it. Its features, its strengths, its weaknesses, take a look inside, and maybe a little bit of schematic analysis. So stay tuned. I remember it was many years ago I saw the Bugera line drop and it's like, cool, Behringer's cloning tube amps now, cheap tube amps, nice. That was back in the day when cheap tube amps were few and far between. On one hand, you're kind of stoked because they're cloning famous models and making them affordable. On the other hand, you're kind of like, well, I don't trust Behringer. Like many other people, musicians especially, I've worked in audio, live audio. I've used a lot of Behringer gear. Sometimes it served me really well. I have an old MX9000 console that I'm actually quite fond of. I've done great work with it. But then other stuff, it's kind of like, how are you broken already? I got a pair of Truth monitors that you just plug them in and they're just noisy for no reason. Haven't felt like fixing them. Don't do studio work anymore. Now this particular guy is a clone of the famous 1959 Super Lead. And in my opinion, it does it really well. The second I plugged into this amp, I got a tone out of it that I expected to get out of it. And I've thoroughly enjoyed playing it. Looking at the front panel, we got our typical presets, treble, mid, bass. Like a good Marshall, you pretty much dime out the bass because they don't have a lot of low end. Volume 1 and Volume 2. Volume 1's going to be your bright channel. Volume 2 is going to be your dark or normal channel. I call it the dark channel because it's actually really dark. It's almost like pointless. It's so pointless, I wonder why they have its own input for it. It's like absolutely, I haven't found any use for the dark channel alone. But that's okay. Because of the way they do the inputs, they have a parallel input. You pretty much plug into there and then blend the two channels as you see fit. And that's exactly what you do because the bright channel is really bright. So I might have it right, anywhere that I want it to be. And then I blend in a little bit of dark just to fill out the tone. That's how you use it in the standard mode. But it has the mod on it, a Cascade mode. Remember, I've talked about the Cascade mod in other amps before. We plug into there and then it routes through the two channels. Here I have a schematic that roughly shows what's going on. That's the Cascade input. It's going to go through channel 2 first, this guy here, the dark channel, and then the relay routes it around into the first channel, the bright channel. So this would technically be your main gain, and then this would be a gain blend. But again, it's two gains. You kind of blend them as what you want. Instantly, you could get some JCM 800 tones out of this. But however, in the JCM 800, normally this gain stage here would be a cold clipper, a 10K with no bypass. That's not the case here. So this thing actually has well more gain than the JCM 800 stock. In fact, that's something I like about it. The JCM 800, I have one. It's a good amp, but I can't play it without something else plugged into it, like a pedal and overdrive. I guess if you want to play clean, this guy, I can plug into Cascade and I can do bluesy stuff all day long or just light crunch. Even the normal channel, non-cascaded, you can just plug in and play. You don't even need to crank it, which is another interesting thing about this amplifier. It is one of the cliche loud amplifiers because you need to bring these knobs up before it gives you any tone at all, and it has no master volume, or does it? It actually does have a selectable phase inverter master volume. As soon as you press the button, even though it's set to 10, you see a volume drop right away. But as you turn it down, it starts to sound like garbage. Yeah, I, am not a big fan of phase inverter master volumes. I don't like distorting the phase inverter at low volumes. If you're gonna distort your phase inverter, you need to have your power section distorted too, or else it doesn't just sound right. The phase inverter master volume in this amp in particular sounds like crap. I'm probably not testing it in this video. I'm gonna make a second video where I go through the tones that this amp can make. Check that out if you wanna see what I mean. It gets like, it's like, why would you even want to sound like that? Showed it to my buddy. His reaction was, ugh. Yeah, no. this has no business being on this amp. Bugera, if you're listening, instead of like telling me to take this video down because I heard you're kind of sketchy like that, change that to a standard master volume. Get rid of that phase inverter crap. Whatever you got going on there, it doesn't work. However, as a bonus feature, we have an effects loop. You can turn it on and off as selectable +4 or -10. Herein lies one of the flaws of this amp. I found something resembling a schematic for this amp that shows how it works. And then here is the effects loop. Coming off the tone stack, assuming this relay is not in the way, it goes to this voltage divider here. That sets the output level, +4, -10. It simply switches down and changes the configuration of that voltage divider. Then we have a typical TL072 op amp. Just directly feedbacked, and that's going to be our send buffer. It's probably just in there to do an impedance trickery, to drive the effects. It returns here, and then boom, it just flows through, gets recovery stage, and then out into the phase inverter. Now to set the gain, we got our typical feedback loop, and we got an arrangement here that looks very similar to a DOD250. It's a very basic way of doing it. This works in line with the +4 -10 switch. Basically, in this position, there's 2.7K shunt to ground, but if we flick the switch over, it just directly grounds out this feedback loop. That's going to kill the amount of signal that can pass in the feedback, causing the op amp to have more gain. So this is the flaw that I find with this. Maybe it's picking up a ground loop because unlike some other amps, it doesn't have the 10 ohm resistor here to break the loop. But when I flick it over to -10 mode and the gain on this stage gets boosted, there's a hum, a very slight hum. Not very distracting, but a hum nonetheless. That hum is completely not present in +4 mode. However, in +4 mode, I hear the circuit distort. Basically, if I'm running the amp in cascaded mode and I'm doing one of these where I am running the preamp hard without a master volume coming off the tone stack, this first op amp stage gets hit with a lot of signal. And I'd be in the zone there playing. Here's like pucky noise. Sound like my string hit the pickup, but it didn't. And sometimes you'd hear like little pops and clicks. Now I got a frickin' dimer out to do that. And normally within the design intention of this amp, it is going to be stupid loud at this point. You're probably not going to hear that over top of the phase inverter distortion and the power tube distortion. To top it all off, that is in +4 mode that it does that. When I set it down to -10 mode, I don't hear that. So it's like you need the -10 mode to attenuate what's hitting this first op amp so that it doesn't distort. Now the only reason why I'm hearing this is because of how I'm running the amp, which is non-standard. And the only reason why I want it in +4 is to avoid that slight hum when I'm playing at bedroom volume levels. But realistically, not a lot of stomp boxes are going to support +4, so you're going to be using it in -10. So maybe this is just something that slipped past Behringer's or Bugera's testing. How I've been using this amp, realizing that there's an effects loop between the phase inverter and the tone stack, I'm like, well, that's just a great place to insert a master volume. So this pop can, soda can, looking dealy right here. We just have a 1 meg potentiometer in there. I accidentally wired it backwards, but I'm actually liking the curve of that reverse audio taper I'm getting. I can actually subtly adjust it at low volumes without it running away. Not like some amps that's like quiet. The gain knobs on this are kind of like that. I had a spare pot, I had spare jacks. All I needed was some sort of metal container. I'm sitting here thinking, oh, what can I use? And then I saw this it was packaging for vape juice. There'd be a foam and a glass bottle in there. They don't make them like this anymore, but I'm like, hey, that's perfect. So I got this soda can volume control. So I plugged that into the effects loop and perfect. I got a master volume and it works so well. It opened this amp right up. I've been playing it constantly since I figured out that trick. You don't need to crank this amp for it to sound good. I don't think anyway. Sure, maybe there's some classic tones that you can't get unless you crank it. It sounds awesome cranked, but there's lots you can do at low volumes too, especially if you're playing with pedals like overdrives and whatnot. Now again, I don't think they intended you to use it this way, so maybe that flaw with the effects loop is only something that's happening for me. But either way, if this was my amp, I would mod out that phase inverter master volume and make a conventional one. Now, of course, the tubes they give you with this amp are clearly Chinese. There's an A, a B, and a C. Now, there are A and B models of the Shugang 12AX7 tubes, which they've labeled ECC83 to just keep it with the British vibe. But then the C, well, there are Cs too. They would be like some sort of premium version or a selected version that has slightly better specs. That would be in the phase inverter. And then the power tubes they give you, well, they're Shugang EL34s. And it's funny because they're not the same height. There's like some quality control deficiencies here. I wouldn't be surprised if I put these into a normal amp, they aren't matched. The way the Infinium works is you do not need matched tubes. So, you know, that might be part of the price point of this amp. They were able to get B-stock tubes from Shugang. It's not that they're gonna sound bad, that just maybe they're not matched. Now the enclosure itself is clearly MDF. That's not a bad thing. For something like this, I'll take it. The upholstery, and key term upholstery, this is not Tolex. This is very fragile upholstery. If we look here on the amp, it's already gotten scarred up and would continue to get scarred up if you're not careful. Oh, this is actually not too bad. We can see they're using carbon comp resistors. Oh, they have some small what look like quarter watt metal filming going on in there. Mostly half watt, even 1 watt. No, those look like half watt carbon comps. That looks like a 1 watt metal oxide. A lot of fusing in here. Detection wires, nice harnesses. 105C rated capacitors. That is something I was not expecting to see. That's kind of cool. All PCB, of course, but that's not necessarily a bad thing. As I recall, when these amps came out, part of the marking wank talked about how they re-engineered these things. They didn't just straight up copy the 1960, the Super Lead. They took the Super Lead schematic and they re-engineered it to modern spec. That means the layout and the PCB design is going to be optimized. You know, back in the days of Marshall and Fender, it's just kind of like, okay, we got to build an amp. Okay, there's all the components laid out. And debatably, some of what they did was wrong. I've worked on some older amps, studied this older design, some of the way they do grounding schemes, and it's not technically correct based on what we know of electrical engineering now. Bugera's taken those concepts and engineered them into this amp, and the result is you're gonna hear, when I do the listening tests, it's really friggin' quiet. Here is the effects loop section. We have SMDs on the effects loop. Well, that's not a deal breaker, but it's going to make it hard to service. We have an SOT type op amp there, which is going to be tricky if I want to replace it. The phase inverter master volume looks strange because it is not dual gang. Usually they're dual gang, but there is just a single gang pot and a wire going over to the board over here. That's suspicious. I would like to know how that works. How do you have a post-phase inverter master volume with only one gang? Now, of course, I don't have a proper schematic for the Infinium model. The schematic I have is for the non-Infinium version. It also doesn't have the Cascade preamp in it. It looks like some of the component values here do equate to what I'm seeing here. It almost looks like we can cut this PCB right here, remove this chunk without actually damaging the rest of the circuit. And then put a normal master volume in here. A normal one, bud. Just this switch might be tricky. Because, you know, that switch isn't a bad idea, being able to disable that feature. Yeah, I'm not hating it. Pretty much everything that is typical to a tube amp is within tube amp spec. It's not like a friggin' Blackstar that's all SMD and you're kind of like, RMR. So seeing here, we have the Infinium module, right? You got a voltage regulator there to allow it to operate a generic Atmel microcontroller. That's basically a mini one-chip computer. It's going to have an EEPROM. You're going to be able to program it to do whatever you need it to do. So even though that's a generic part you can buy for cheap online, well, it's going to have Bugera's proprietary software baked onto it, and that works along the lines with this chip here. Now I have a schematic, not for this amp, but for the Tri-Rec, and I imagine it's going to be done much in the same way. Yeah, IC4 doesn't have a part number here either. I Googled the part number, nothing came up. Maybe that's something proprietary. So the long and short of it is over here, you got your power tubes. The cathode of your power tubes go down and out to this other circuit. Basically this relay switching matrix where it comes in and then, you know, the switch can either disable the tube or it passes out through to connection C, A, B, C, and D respectively. A, B, C, and D is seen here on the ground bus with a 4.7 ohm resistor. That's going to be your current sense. But A, B, C, and D are also connected up here in the Infinium circuit. So we got these op amp modules here, A, B, C, or D, and these guys are gonna do, they're gonna read that current sense information and send it out to connection tube 1, 2, 3, and 4, which is on the Atmel controller, tube 1, 4, 3, 4, blah, blah, blah. This pupper right here is gonna be programmed to recognize what it's seeing, and then it spits out information, DIN, over to this IC4 that we can't find specifications on, but I'm gonna imagine it's some sort of digital potentiometer, because then it outputs these signals volts A, B, C, and D, which goes to another op-amp driven module that takes that signal and controls this transistor to regulate the amount of negative voltage. It sends it out to a connector called A1, B1, C1, D1, which back at the power amp section we find connected to this control grid of the tube. Here's 100 volts. That's going to be bias voltage. I saw the 100 volts over in the Infinium circuit too, but chances are whatever that transistor is doing is going to bleed this 100 volts to regulate these tubes. And there's one on each individual tube. That is actually really friggin' cool. I tried it with the Tri-Rec, if you saw that video. I put a bunch of completely different kinds of tubes in there and it just worked. Now, in order to do a conventional master volume, well, it might be cool that we have this situation going on. I hazard to guess if I look at the 1960 schematic over here, X41 to X32 is the signal output. Do we have X41 on here? X41 right there. Yeah, that's right close to the treble knob. And that feeds down into X32, so they kept the same part numbers. That's freaking perfect, bud. We just have to take this one wire between there and there, intercept it, route that to a master volume knob. A master volume mod on this amp would be stupid easy. Stupid easy. We could just freaking have her come back here, cut this chunk of PCB off, install the knob back here where, you know, we already have a knob in place. We might even be able to use that same potentiometer if it's not like a stupid low value. If it works like a phase inverter master volume is supposed to work, it's probably a 1 meg. Depending on the layout of this circuit, we might be able to use it as is. Part number is 11J2. Is a 1K potentiometer. No, we wouldn't be able to use that. They paint these PCBs black, which looks cool, but makes it hard to find what's going on here. It's connected to C29. That's right here. Oh, is it one of those ones that spans across here? Oh, it does look like there's a version where it just has a single pot going across the tube output pins. And if it's connected to C26, yeah, that would be consistent. Either way, it'll be easy to delete. You know, I don't feel like this amp would be too hard to work on in mod, really. Pretty standard PCB. You can kind of get at some of these traces from the top. In actuality, like taking apart this amp for service is going to be easier than a lot of amps because it's modular. Like if you wanted to work on the preamp board, you can pretty much disconnect everything, just kind of pull this up. Or, you know, some of it's going to be on here, just pull that off. That's just a little bit flims. You know, it's kind of where they cut corners on an amp like this. You know, we got these tiny little screws. They're going to be made out of a softer metal. The chassis is like not too bad. MDF wood, it's not going to be anywhere near as robust as like a higher end brand name amp. Well, I don't know. New brand name amp quality is probably not much better than this, but old brand name amp, like my trainers look like frickin' bomb shelters compared to this thing. Not, you know, it's adequate. You know, it's heavier than my 800. Taking a quick trip to the city of Curio. We're going to pop its EL34s in here and see if they actually match. So the first thing I'm noticing is these tubes are cold. They're biasing a lot cooler than the tubes that I had in there. I'll bring them up to about, on this amp, like 37. Okay, so one tube's 36 point blah, blah, blah. Let's check the other tube. 25. That's an 11 milliamp difference, which, to be fair, isn't that bad. I've bought new sets of tubes from reputable suppliers that were farther off than that. Or at least tubes that I have will drift farther than that. 10 milliamps isn't that bad. This set, the second, because it had 4 tubes, these ones are height matched. So let's swap on these and see what they have to say. Oh, they're tight. Wait, this one's definitely hotter. All right, so without changing the bias, 37. Oh, that puts it damn near, oh, look at that. That puts it damn near tight match with one of the other tubes. And oh boy. So of the 4 tubes we got in there, 3 match perfectly. One is 10 mil off, but that's not a deal breaker. So these are actual good tubes. They're not some sort of crappy B stock. They're actually matched and quite well. They're a brand new set. This is a brand new amp. Like it hasn't been sold. It got lent to me from a mom and pa shop, and like brand new tubes to the match. It's tight. So looking at the top of the amp, we got ceramic tube sockets, we got bear claw retainers. Bear claws are a pain in the ass. I removed them right away because they don't support all tubes we could possibly use. The main power tube sockets are chassis mounted and they're flush. So you remove those guys, you're not gonna have any problems seating a larger tube in here. Can you stop? Now they are PC mounted, so they shouldn't come right off with these screw removals. Yeah, there we go. But chassis mounted sockets are a nice touch. Now the preamp tubes, they're PC mounted, not chassis mounted. They sit rather down in there and come with these stubby shields. Now one thing nice is they do still have the retainers with screws, which means if you were to gut this amp and rebuild it into something else, you'd probably be able to mount chassis mounted tube sockets on there without much problem. Now one thing that we do got going on here in the power supply section, which is worth mentioning, we have, you know, the normal kind of thing going on here with the main power supply. Bridge rectifier goes out to the standby switch for turds, goes to plate. Then we have, you know, dual 100s in series making a 50U. Then with this link here, it goes out to the choke and comes back. But the weird thing is we got 2 1K resistors in parallel with the choke. I've never seen that before. Usually it's one or the other. So 2K resistance isn't going to let a lot of current pass. Chances are the choke's doing most of the work. But that's weird. It's almost like the choke is pointless, but no, not with 2K. It's just weird. I've never seen that before. Goes out to the screen. Then we have another dual 100 making 50U, then the 22K, then a 100U. Now this is friggin' weird. Normally we don't have a 100U following 50U. So that's another thing that I'm seeing here that's different. Now for the filaments, we have 2 different filament supplies. We have what appears to be the typical 6-volt one here. That's going to be for the power tubes. We have our 100/100 artificial center tap, decoupled with a 100U capacitor. I've seen capacitors on center taps before. That's kind of good though. It provides isolation. But then we have a separate filament supply for the preamp tubes. And we're going to notice after rectification, it's 24 volts positive and 24 volts negative. So yeah, they have, it's a center tapped. It's 24 volt, or no, it's going to be 48 volt center tap. And then we have 51 ohm dropping resistors going out to plus and negative filament. And then this is how it's done. We have our center tap here, and then we got 3 coils on one side, 3 coils on the other side. So the center tube is it's right on center, being fed by 2 different supplies, and then these guys are just running completely in series. That means you can't use adapters to put Russian tubes in here. Wouldn't be compatible. I don't like it when they do this kind of thing because it's very dependent on the tubes. The heater spec is usually close enough you can get away with it. If you have one tube that's particularly out of spec compared to others, it could cause other tubes to suck back more current. So the current draw of a single coil in a single 12AX7 is 150 milliamps. When you run them in parallel in a normal amp, it's a total of 300. Running them in series like this, you're going to up your voltage, but you're going to have the same current draw. So that's going to be 150 milliamps total. So take a 51 ohm resistor and multiply it by that current draw. We're expecting to see 7.65 volts of drop. That means that's going to be a total of 16.35 volts. Divide that by 3. Each tube's going to be seeing 5.45 volts. Now that Yeah, I guess so, right? That's a little bit low, but maybe that compensates for any differences so that, you know, if one's pulling a little bit more or a little bit less, the other tubes don't get overdriven. Let's just take another look at the schematic. So this is a Bugera 1960 non-Infinium, non-Cascade. And here, 1 is the bright and 2 is the dark. So they spec out here, that's pretty much standard, 1 meg, 68K, 68K, 100K, anode, 820 on the cathode. That's kind of not normal, that's more JTM. 680N is consistent. If we look at a super lead, the bright channel has a 2.7K and a 6.8. So this channel is going to have slightly more gain technically. An 0022 coupling capacitor. What do these guys got? A 3.3N. So that's an 0033. A little bit more bass going through there. Volume has a 0047 bright cap. Super lead 005, cool, that's the same. Then a 470 and a 500p, or that in this day and age would be a 470p. Yeah, 470, 470. So it's almost identical except for this value and this value. Now on the dark channel, we have a 820 with a 330 UF capacitor. What do they got in the dark channel here? 250 UF with an 820. A little bit fatter. Moving down the line, again, 820, 680, Marshall Super Lead, 820, and a 680. Yes. Then your cathode follower. Bam, 100K. No trickery there. Just normal, normal, normal. Treble, 250. Bass, 1 meg. Mid, 25. I can tell you right now, it's going to be identical. 470p, 22N, 22N, 33K. What's the super lead have? 30 something K slope. It seems a bit hazy in this schematic. 36, 38, it's in the 30s, 500p, 470, 2222. Okay, that's identical also. The rest of this crap is to taste. 10, 470, 1 meg, 122, 10, 47, 22, 1 meg, 1 meg, 470, 10, 47K. So this is all the same. This is the same. Yeah, the phasor is the same, except there's a oh, that 47K is the feedback? Yeah, that 47K is the feedback. The typical flawed 4.7 against a 25K potentiometer, except with a 1.1 in between. Yeah. Oh, it's different in the super lead. A 5K against a 0.1? That's how it's supposed to be. Weird. 47 or a 100K connected to the 8 ohm tap in the super lead, it says. And what do we have here? Feedback. We have to go over to here. Feedback connects to white. White connects to this switch position, which looks like it might be the 16 ohm tap. No, it connects here. Yeah, it's the 8 ohm tap. Now reading this switch is a bit tricky. Bias doesn't matter. They can do that however they want. 1K screen grid resistors. They are looking at 1K screen grids on here. 1K is the correct value. 5.6K appears to be the grid stoppers that they're using on the power tubes and the super lead. Here we're using 1.5K grid stoppers. I don't know how much that's going to affect your tone. The larger grid stoppers supposedly might prevent a little bit of distortion, which apparently you want in your power amp of this. So now this is the other version of the 1960. This one is more specifically going to be this schematic here. So we'll take another look at what's going on here. This one updates the bright channel to the 2.7, the correct 2.7. Okay, but then it also claims to have a 22N here, then 022, not the 0022. So that is a little bit different if this schematic's accurate. The thing is, this particular schematic is fan drawn, if you will, user drawn. So it could be inaccurate. That says it's C31. Let's find C31 on here. C31, 223K. Yeah, and 022. That's okay. I wouldn't want this to have a thinner tone. So yeah, this is pretty much a straight up, like pretty much slight differences. You know, there's 2 cap values different. This guy and this guy. Otherwise, damn near an identical copy of the classic Marshall Super Lead. And it gets you that classic Marshall Super Lead tone on the cheap. I am iffy on whether or not you'd want to gig with this, because, you know, But hey, if you just want a cheap, good example, because let's face it, the Marshall Super Lead, it's a little dated. It might not be the many trick pony you would want for a live gig, a working musician in this day and age, unless you were a higher pay grade touring professional, in which case you probably own a genuine Marshall. But if you want a cheap but good example of that sound, you can't go wrong with this amp. Especially the Infinium Module makes tube rolling a breeze, something that people aren't doing enough of. But I feel like that is about all I have to say about this amplifier. So you're going to want to stay tuned when I'm actually going to plug this guy in and show you what it can do, what it sounds like. So come check that out. I didn't do the hand gestures this time. And I prevented myself from saying stay tuned more than once. Small victory.